Hi student, this video is about improper integral. We have three types of improper integral. The first one is infinite interval. Infinite interval means either both of the limit or one of the limits involve infinity. For one Roman, we have infinity at upper limits, and for second Roman, we have infinity at lower limit, and for 3 Roman we have infinity at both lower and upper limit. Okay, the second one is infinite discontinuities. So for 1 Roman we have integral of 1 over x squared dx from -3 to 3. And this function actually is undefined as x equal to 0. And then for the second 2 Roman, we have integral of 1 over x minus 1 dx from 1 to 2, and this function is undefined as x equal to 1. If we substitute x equal to 1, we get 1 over 0, mean undefined. Okay, number 3 is infinite interval plus infinite discontinuities. Mean we combine case 1 and case 2. So for 1 Roman, we have integral of 1 over square root x dx from 0 to infinity. So we have infinity at upper limits, mean infinite interval. And then this function is undefined as x equal to 0, mean infinite discontinuities. And then for 2 Roman, we have integral 1 over x squared minus 9 dx. Okay, this integral is infinite interval since we have infinity at lower and upper limit. And then this function is undefined as x equal to positive or negative 3, means this function is also infinite discontinuities. Okay, now let we see how to solve this improper integral. So example 1. So if we have integral of 1 over x dx from 1 to positive infinity, so we can write as equal to limit. Okay, you can take any variable, you can use a, b, k or t. Okay, a approaches to, so we have upper limits to infinity, a approaches to infinity, and then integral, and then 1, 2, and substitute infinity with a, 1 over x dx. Okay, next step, just we need to integrate 1 over x, so equal to limit a approaches to infinity. Okay, integrate 1 over x equal to ln x, and then you need to substitute a minus 1, and then substitute equal to limit a approaches to infinity ln a minus ln 1, and then we substitute limit equal to ln, okay, a equal to infinity minus ln 1. Okay, here ln infinity is actually equal to positive infinity, and then minus ln 1. Ln 1 is equal to 0. So infinity minus 0 is equal to infinity. So we can make conclusion here based on our improper integral. So we have integral of 1 over x from 1 to infinity dx is, since we get infinity means diverge. Okay, next we move to second example. If we have integral of 1 over x squared dx from 1 to infinity, okay, is equal to limit a approaches to infinity, integrate 1 over x squared dx, and then 1 a equal to limit a approaches to infinity. Okay, to integrate 1 over x squared, we can simplify as x power of negative 2 dx. And then equal to limit a approaches to infinity, x power of negative 1 over negative 1 from 1 to a. So, and then substitute value of a and 1. So equal to limit a approaches to infinity. So we get negative 1 over a plus 1 over 1. So equal to, and then we substitute a equal to infinity. So negative 1 over infinity plus 1. So based on theorem, 1 over infinity is equal to 0. 0 plus 1 equal to 1. So we can make conclusion here. Integral of 1 over x squared dx from 1 to infinity is converge. So if limits is exist mean converge. If limit does not exist means diverge. Okay, next. We move to third example. If we have integral of e power of negative 2x dx from 0 to infinity. So we have infinite integral or infinite interval at upper limit. So equal to limit a approaches to infinity, create 0 to a e power of negative 2x dx, and then we need to integrate equal to limit a approaches to infinity, e power of negative 2x over negative 2 from 0 to a. Or we can simplify this equal to limit a approaches to infinity. You can write this as negative 1 over 2 e power of 2x. and then substitute a and 0 equal to limit a approaches to infinity. So we have negative 1 over 2 e power of 2a plus 1 over 2 e power of 2 times 0, and then substitute a equal to infinity. So negative 1 over 2 e power of infinity plus 1 over 2 e power of 0. Okay, e power infinity is actually equal to infinity. So 1 over infinity is equal to 0 plus, and then we have e power of 0 equal to 1. So plus 1 over 2 equal to 1 over 2. So we can make conclusion here. So based on our question, integral of e power of negative 2x dx from 0 to infinity is converged. Okay, next we move to example 4. We have integral of 1 over square root 1 minus x dx from 0 to 1. Okay, for this example, our function is undefined x equal to 1. So we can write as 1 over square root 1 minus x dx from 0 to 1 is equal to, okay, limit, since undefined x equal to 1 is at upper limit, so a approaches to 1. Okay, if upper limit is actually from left, and then integrate 1 over square root 1 minus x dx, and then just substitute. We have lower limit 0 and upper limit is equal to a, and then we can integrate equal to limit a approaches to 1 from left. Okay, for this question, actually we can solve by using method u substitution. So we can let u equal to 1 minus x, du equal to negative dx, or dx equal to du. Sorry, dx equal to negative du. So if we substitute 0a 1 over u power half time negative du, or you can simplify this equal to limit a approaches to 1 from left, integrate from 0 to a, equal to negative u power of negative half du, and then we can integrate this equal to limit a approaches to 1 from left. Okay, integrate negative u power of negative half if equal to negative u power half over half. and then we just substitute u equal to 1 minus x. Limit a approaches to 1 from left actually equal to 2 negative 2 square root 1 minus x is 0, and then substitute a and 0 is equal to limit a approaches to 1 from left negative 2 square root 1 minus x, and then plus 2 square root 1 minus 0, and then substitute 1 minus a. And then substitute a with 1, so equal to limit a approaches, if we substitute we don't need to use or we write don't need to write limit. Then substitute negative 2 square root 1 minus 1 plus 2 square root 1 minus 0. So square root 1 minus 1 is equal to 0. The first term is 0 plus 2 times square root 1 equal to 2. So we can conclude here based on our question. We have integral over square root 1 minus x dx from 0 to 1 dx is converged. Okay, next example number 5. We have integral of 1 over 1 minus x dx from 1 to 2. Okay, this function is actually undefined x equal to 1. So we can write integrate 1 over 1 minus x dx from 1 to 2 equal to, so undefined x equal to 1 at lower limits, so equal to limit a approaches to 1 from right. Since lower limits means limits a approaches to 1 from right, and then we have integral 1 over 1 minus x dx. Okay, lower limits we substitute with a and then 2. So next we just need to integrate this, so equal to limits a approaches to 1 from right. So since denominator is linear, means x power 1, we get equal to ln 1 minus x, and then differentiate this one equal to negative 1, and then substitute equal to limit a approaches to 1 from right negative ln 1 minus 2 plus ln 1 minus a okay, then we just need to substitute a equal to 1 equal to negative ln, okay, 1 minus 2 equal to negative 1 plus ln 1 minus 1. Okay, for the first term, since we have modulus, so you have negative ln 1 and then plus ln 0. Okay, negative ln 1 is actually equal to 0 and then plus, okay, ln 0 is actually if we base on graph of ln, this one, okay, if we have ln 0, our graph is actually approaches to negative infinity, so ln 0 is negative infinity or equal to negative infinity. So we can conclude here, okay, integral of 1 over 1 minus x dx from 2 to 1, sorry, from 1 to 2. It's actually diverge. And example number 6, if we have integral of 3 over x minus 2 dx from 0 to 3, and this function actually is undefined at x equal to 2. So actually we can write this function is equal to, we can separate the interval, the integral equal to integrate 3 over x minus 2 dx plus integrate 3 over x minus 2 dx. So you have lower limits equal to 0 and upper limits equal to 3, and our x is undefined as 2. Okay, next you can write is equal to actually to this is equal to limit a approaches to 2 from left, integrate 0 a 3 over x minus 2 dx plus a limit a approaches to 2 from right, get from a to 3 over x minus 2 dx. Okay, for this question we don't need to solve for both, but actually we can check term by term. We can check term by term. Is one of the term is diverge, mean both term is diverged. But if both term is converged, then this overall function integral is diverged. So you can check for the first term. We have a limit a approaches to 2 from left, 0 to a 3 over x minus 2 dx is equal to limit a approaches to 2 from left, have 3 ln x minus 2 is 0, and then substitute is equal to limit a approaches to 2 from left, we have 3 ln a minus 2 minus 3 ln 0 minus 2. So next, just substitute a with 2, so 3 ln 2 minus 2 minus 3 ln, okay, 0 minus 2 is negative 2, but we have modulus here, means ln 2, for 3 ln 0 minus 3 ln 2. So for the first term, okay, ln 0 is actually equal to negative infinity, and then if you minus with value, if you get this is a value, you still get negative infinity. So we can make conclusion here based on what we checked. We have limit, we can make conclusion integral of 3 over x minus 2 dx from 0 to is a diverged. So over x minus 2 dx from 0 to plus okay 3 over x minus 2 dx from 2 3 is also diverged. Okay, since we get the first term is diverged, so we can make conclusion for the another term. If we have we checks and the first term is converged, and then you need to check for the second term. So if converged plus converged is equal to converged, is converged plus diverged equal to diverged. Okay, that's all. Thank you.